Hi there, this is the Year 4 science video about evaporation and condensation. But before we actually go on to evaporation and condensation, because we haven't been in school for such a long time, we're just going to do a quick recap of states of matter. What are the three different states of matter? Have a think. There's solid, liquid, and gas. What are the properties of a solid? Have a think back to our lessons last term. Solids stay in one place and can't be held. The only time they move is when a force has been applied to them. Solids keep their shape. They do not flow like liquids, and there's a similar reason they only change shape when a force has been applied to them. Solids always take up the same amount of space and they don't spread around all around like gases, and they can be cut or shaped. And even though they can be, some can be poured, so you can pour sugar and you can pour salt, they are still all solids because they're made up of little particles, and those little particles keep the same shape and the same volume. What are the properties of a liquid? Have a think. They can always be poured, and they're certainly not very easy to hold. Try holding some water in your hand and it all drips down through your fingers. Liquids always take the shape of the container that they are in, so that means they are continually changing shape depending on whichever pot or glass or cup they're in. And even when liquids change their shape, they always take the same space, so their volume always stay the same. What are the properties of a gas? Gases are often invisible. There are only a few gases that you can actually see, and we probably won't ever come across those. Gases do not keep their shape. They do not always take up the same amount of space, and they can spread out. You can see all those particles moving around really quickly, and they can change their shape and their volume to fill up whatever container they're in. And they can be squashed, or the scientific word for that is compressed. Right. We've got three different pictures here. One's a solid, one's a liquid, and one is a gas. Have a think. Which one is the solid and why? Why do you think that? Think about the particle arrangement. It's number two. And the reasons why are that all the particles are closely packed together, they're closely arranged, and they've got a strong bond with each other. Now, that bond means an attraction. So these particles have a strong attraction with each other. Okay, which one do we think is our liquid? Number three. And why? We know that they're particles, they move around, they can slide over each other, they can move freely around, and they don't have as strong a bond as the solids do. So it's a slightly weaker attraction amongst all the particles. That leaves number one as gas. And their bonds are very weak, so there's very weak attraction amongst each of the particles. And each of those particles have lots more energy, and they move round and round and round very, very quickly, and anywhere here, there, everywhere. In our previous lessons, we learnt that materials can change their states of matter depending on the heat or the lack of heat. Can you think of any examples where this happens? Here, I'll give you a few of my ideas. A kettle boiling. So it starts off as cold liquid, and then it gets heated up, and then it turns into water vapor, which is a gas. We've got a solid ice lolly, which when heated up will melt into a liquid. Same with an ice cream, solid ice cream, but when it gets heated up, then it turns into a liquid. You may recognize these ice cubes. So solid, that when heat is applied to it, then it melts into a liquid. Now you might recognize the blue and yellow ice cubes from our investigation last year, where they melted into and mixed into a green liquid. Then we have chocolate. And now solid chocolate, if it's held in the hand for long enough, it will start melting and it will melt into a liquid. Luckily, I don't ever have that problem. And then you have puddles. Think about it when it rains, it leaves a puddle and then the puddle goes and it evaporates into a gas, into the air. This point is really important to note that if the state of matter does change, the material still stays the same. If you evaporate or condense a material, it will still be the same material as before. So if you think about water, you've got liquid water, it turns into ice cubes, but that ice cube is still water, but it's just frozen water, solid water. And then if you've got a glass of water and you heat it in the kettle, then that's going to become water vapor, which is a gas, but it is still water. Okay, imagine boiling a kettle. Now, I suggest you don't do this unless you've got an adult with you. So let's have a look at our kettle. We've got our water at the bottom, and you can see that the particles very weakly bonded together, but they can move and slide around freely over each other. Now, as the water is heated, as we can see in this picture, the particles absorb more energy, which means they take in more energy and they become a lot more energetic. Now, this means that the bonds with the other particles are starting becoming weaker and weaker. And this is in this final picture, you can see that the particles have absorbed so much energy that the bonds have completely broken. And at this point, where the liquid has changed state and become a gas. And in that last picture, you can see a particle of water vapor that has escaped from the kettle. This process of going from a liquid to a gas is called evaporation. So anything that goes from a liquid to a gas is evaporation. Let's have a look at this picture, a rain cloud. What do we have in a rain cloud? Amongst other things, you have water vapour, which is the gas version of water. And when a gas is cooled, the opposite to evaporation happens, and the gas turns into a liquid. And this process is called, I'm sure you can guess, condensation. Apart from when I mentioned the rain cloud earlier, when have you seen condensation? Have a think when you've seen water vapour change its state into liquid water. Here are a few of my ideas. We've got a glass with a cold liquid in it, and the water vapour has touched the cold glass and it's changed from the water vapour to a liquid. And here we've got a window, which is a cold window, and it's very hot inside, and the water vapour has hit the cold window and it has turned into a liquid. And here you've got a mirror, a bit like my mirror in the bathroom after the shower, where it's very, very hot and steamy with lots of water vapour in the bathroom, and then the mirror is very cold, and that cools down that water vapour and turns it into a liquid. So here, the water vapour in the air comes into contact with the cold glass, and when the particles of water vapour touch the glass, they lose energy and their bonds become stronger.